let's be real for a second. We are absolutely swimming in data, but more data doesn't automatically mean we're any smarter. So today, we're going to talk about how the connections hiding inside all that data are the real key to unlocking intelligence, especially now with generative AI changing everything.
And this quote, it just hits the nail on the head, right? We've become experts at collecting and storing data in these massive data lakes and warehouses. But actually using it to find something meaningful? Well, that's a whole other story. It's created this weird situation where companies are data rich, but completely insight poor. And that leads to a huge question, a real what if moment. What if we've been so obsessed with collecting every little data point that we've completely ignored the most valuable part, the relationships between them? What if the problem was never the amount of data, but our inability to see the web that connects it all? To get why this is such a big deal, just look at how we usually store data. On the left, you've got your traditional relational databases. Think of them as really, really rigid spreadsheets. Everything's locked in tables, and if you want to connect data from different tables, you have to run these complex and honestly painfully slow join operations. But then, look to the right. That's a graph database. The entire world is built on two simple ideas: nodes, which are just things, and relationships, the lines connecting them. It's way less like a static table and much more like a flexible living mind map. All right, so this is a whole new mindset, really. Let's dig into what it actually means to think in connected data, because it mirrors the real world in a pretty cool way. And you know what's beautiful about it? It is ridiculously simple. At its core, you're only dealing with two things. You've got nodes, which are just entities, a person, a product, a company, and then you have relationships, which, you guessed it, describe how those nodes are connected. That's literally it. It's just an incredibly natural way to draw a picture of the world. So what does this look like in practice? Let's build a tiny piece of a graph right now. We start with a node, and we put it in parentheses. We give it a label, like -person, so we know what kind of thing it is, and then we can add properties, like a name. And just like that, we've brought a digital version of a person named Rosa into existence. Okay, easy enough. Let's do another one. Same exact idea. A node with a label place and a property telling us the city is Berlin. So now we've got two separate facts floating around. But right now, they're just two lonely dots. The real magic happens when we connect them. And boom, this is where it all clicks. We link our two nodes with a relationship. You draw it with dashes, and you put the type of relationship, in this case /lives in, inside square brackets. The little arrow shows you the direction. All of a sudden, it reads just like a sentence. Rosa lives in Berlin. That simple pattern is the fundamental idea behind how you ask questions of a graph. So you might be wondering, okay, that's neat, but what makes it so fast? Well, the secret sauce is this concept called index-free adjacency. With those old relational databases, to find a connection, you have to scan through giant tables. It's like looking for a name in a massive phone book every single time. In a graph, each node has a direct physical pointer, like a direct phone number, to its neighbors. The relationship is the pathway. So finding what's connected is lightning fast because it doesn't matter how big the whole database is, only how much of it you need to explore. It is an absolute game changer for performance.
All right, so we've got the basic building blocks down. Now, let's talk about how we move from just linking random data to creating real, actual, intelligent knowledge. Now, here's a really key point. Not every graph is a knowledge graph. A knowledge graph is special. It has an organizing principle, a kind of schema or model that adds meaning and context. So instead of your application code having to figure out what everything means, that intelligence is baked directly into the data itself. The data basically becomes self-describing. And why should you care? Well, the payoff for doing this is massive. Your systems get way simpler because the data is doing the heavy lifting. Think about it. Data you gathered for, say, fraud detection now has enough built-in context that it can be used for product recommendations, and you don't need a huge new engineering project to do it. This is how you finally start to break down those data silos we all complain about. Okay, this all sounds great on paper, but where is this stuff actually being used? Let's jump into some real-world examples where graph tech is making a huge difference. Let's start with a recommendation engine. Everybody's seen one of these. It is a classic graph problem. You just start at a user node, then you follow the relationships to things they've liked. From those items, you fan out to find other people who like the same things, and then you hop back to see what else those people like that your original user hasn't seen yet. It's just a pathfinding game, and it's exactly what graphs are built for. But it goes way beyond just movie recommendations. For fraud detection, you're literally hunting for rings of suspicious accounts that are all secretly connected. In a supply chain, you can ask, hey, what happens if this one factory in Vietnam shuts down, and see the ripple effect instantly. In HR, you can find the one person in a 50,000-person company with the perfect niche combination of skills for a project. These are the kinds of gnarly, complex questions that give traditional databases a headache. But graphs, well, graphs just eat them for breakfast.
And now for the part I know you've been waiting for. This is where things get really exciting. What happens when we plug this powerful, connected data technology into the biggest revolution in tech today? Generative AI. Look, we all love playing with large language models, but we've all seen their weird side too. They have that knowledge cutoff, so they're clueless about recent events. They have the infamous hallucinations, where they just make stuff up with total confidence. And maybe worst of all, there's no traceability. You can't ask an LLM, hey, how do you know that? And get a straight answer. So the whole industry has been working on a fix, and the standard solution is a technique called Retrieval Augmented Generation, or RAG for short. The idea is actually pretty simple. Before you let the LLM answer, you first go and retrieve relevant facts from your own trusted data. Then you hand those facts to the LLM and say, okay, answer the question, but only use this information I just gave you. It's like giving the AI an open book test. And this is where it all comes full circle. What if that open book we give the AI isn't just a pile of disconnected documents, but a rich, structured, deeply connected knowledge graph? Well, that's the whole idea behind GraphRag. You're not just feeding the AI random facts, you're feeding it facts plus their context and relationships. And that leads to dramatically more accurate, traceable, and intelligent answers. And the latest systems get even smarter. They use something called an agentic approach, which is just a fancy way of saying they use one LLM as a kind of smart project manager. It looks at your question and figures out the best strategy. Does this need a simple search, or does it need a deep dive into the graph's connections? It picks the right tool for the job, fetches the right facts from the knowledge graph, and then hands everything off to another LLM to put it all together into a final, coherent answer. It's a true reasoning process. So, look, if you remember just one thing from all of this, let it be this. For decades, we have been obsessed with collecting individual points of data. But the real gold, the truly game-changing insights, they're almost always hidden in the relationships that connect everything together. So I want to leave you with a final thought. Your data, right now, is already telling a story. It contains a hidden network of your customers, your products, your entire process. The question isn't whether you need to collect more data. It's about whether you're ready to see the powerful connections you already have. So the real question is, what are you going to build with them?